Good evening, everyone. Good morning, classmates. Good morning, ma'am. So my name is Ruby Reyes, and I'm here to discuss EDAS method from multiple attribute decision making, or MADM. So the primitive notion of rough sets and enthusiastic fuzzy set (IFS) are general mathematical tools having the ability to handle the uncertain and imprecise knowledge easily. So EDAS, or the evaluation based on distance from average solution method, has a significant role in decision-making problems, especially when more conflicting criteria exist in multi-criteria group decision-making, or the multiple attribute decision-making (MADM) problems. So what is EDAS? EDA's method was introduced by Gorabi. He proposed a new method called EDAS for metric criteria in metrics classification. So it ranks the alternative by calculating the positive distance and negative distance between each alternative and the average alternative. Here we are identifying positive distance and negative distance between each alternatives and average alternatives. The good performance of the EDAS method is in solving the metric classification problem. EDAS is a simple yet effective method of a MADM, or the multiple attribute decision making. So EDAS is the evaluation based on distance from average solution, is a new and efficient MADM method. The desirability of alternatives in this method determined based on distances of them from the average solution. So EDA's method is very useful when we have some conflicting criteria. The best alternative in this method is related to the distance from the average solution, or EV. In this method, we have two measures dealing with the desirability of the alternatives. The first measure is the positive distance from average, or PDA, and the second is the negative distance from average, NDA. So these measures can show the difference between each solution alternative and the average solution. The evaluation of alternatives is made according to higher values of PDA and lower values of NDA. Higher values of PDA and the lower values of NDA represent that the solution alternative is better than average solution. So suppose that we have alternatives and M criteria. The steps for using the EDAS method are presented as follows. So step 1, select the most important criteria that describe alternatives. So this means before you start with a problem, you need to identify the alternatives and the criteria. So it is presented in a matrix form. So step 2, construct the decision-making matrix as shown here. So where Xij denotes the performance value of ith alternative on jth criterion. So for example, if these are the criteria, then we have to calculate the average for each one. So for all of these criterion. Step 3, determine the average solution according to the criteria shown in this figure here the formula. Step 4. Calculate the positive distance from average PDA and the negative distance from the average or NDA matrices according to the type of criteria, the cost and benefit. So the formula would be this following. Step 5. Determine the weighted sum of PDA and NDA for all the alternatives. So we have a summation, summarize or the summation of positive distance average and the negative distance average. Step 6. Normalize the values of SP and SN for all alternatives. So these are the formula for the normalized sum of negative NSNI and the normalized sum of the positive NSPI distances. Step 7, sorry. Calculate the appraisal score or AS for all alternatives. So the formula would be the average of NSPI and NSNI. Step 8. Rank the alternatives according to the decreasing values of appraisal score, AS. So this is the final step. So the alternative with the highest ES is the best choice among the candidate alternatives. So we can classify the alternatives with respect to this ranking. So here have the application of EDAS method using Excel. So I will show you the application using Excel. Sorry. I have here the sample calculation of EDAS method. So suppose this problem, the blue color is the blue criteria is the cost criteria. So this one. And the pink is the benefit criteria. So supposing of this problem or this example, the data here is the gadget cost and the application specs of a gadget. So first, we have to step 1, select the most important criteria that describe the alternatives. So we have here the cost, the weight, the RAM specs of the gadget, screen size, and the storage capacity. So given this data, we need to calculate the positive distance from average, negative distance from average, weighted sum from PDA, weighted sum from NDA, or the negative distance average, and then the distance or the normalized sum, then the ranking. So let's start here with step 1. So step 1, select the most important criteria that describe the alternatives. So we already select or determine the criteria that we are going to use. So this is the cost, the weight, RAM, screen size, and the storage capacity with these given values. So number 2, step 2, construct the decision-making metrics. So these are the decision-making metrics: the positive distance from average, the negative, then the weighted sum of positive distance and the weighted sum for negative distance. So now we are going to go to step 3. Determine the average solution according to all criteria. So we will calculate the average. So calculating the average, we have this formula equals the average, open parenthesis, and we will click here the first value for criteria 1 up to the last alternative, close parenthesis, then enter. So we will drag this one so that the value of all criteria will be shown. So like this. So if we want to have fewer decimal points, so we will just have this one. We'll have the 2 decimal places. Next is we need to calculate, or step 4, calculate the positive distance from the average PDA and the negative. So this one and this one, we will calculate this one. So calculating, according here the formula, it is so equals PDA is equal to max 0, comma C5 C3. So this one, first brand, minus, said here is the average, so click this average. Then because we want to copy this cell, the formula of this cell, so we'll click F4 twice. Then close parenthesis over the average. So we will click F4 again. Sorry. Okay. So we will copy all the way. Then if we want to copy the formula to the next cell, we just remove this $sign here, so that we will no need to input everything again. So copy, then drag down. Okay, then for this value, the the benefit value. So it would be max this value minus the average sorry, we have here max 0, then over the average. Drag down. Then we will copy the formula to the next cell. So we will use 2 decimal places for these values also. Hindi man makuha na. Okay. 2 decimal places will do. Next is the negative average. So negative average, negative distance from average is equal to, as the formula states here, max 0 the formula is in reverse, so we will have the average first, then minus this value, so we will put $sign here so that the formula will not be destroyed, over the average. Okay. Then here also is max 0 average first minus this value over average So, okay, so we'll have two decimal places also. Next, we need to calculate the weighted sum from PDA, or the positive distance average. So by calculating these values using the step 5, or step 5 is determine the weighted sum of PDA and NDA. So using this formula. We will have this equals here. This value from positive distance from average times this one. It's a weighted matrix. So, sorry, until here only. Then drag down. This one, the benefit side is equal to from the positive times this one. So, okay. So we also need to have the sum of this weighted PDA. So the sum, the average. Oh no, sorry. The sum of this PDA, weighted PDA, is equal to the sum of these values. Drag down to get all the sum of the entire alternatives. So we'll go to the weighted sum from negative DA, or the negative distance average. So it would be equals the negative here. This is the negative distance from average times the weighted is equal to 0.04. So drag the blue cell, then down. The benefit side is equal to the negative alternative. This one times okay. Just copy the formula all the way and down. So we also need to take the sum of these values. So the sum of all this one. Okay, drag down to get the sum of other alternatives, I mean. Then we have to calculate we said here the step 7. No, we are on the step 6. Normalize the values of SP. and is n for all our alternatives. So these values, it is the formula for this one is SP. It is equal to this one said here, the SP1 is PI over max of all. So this one. Then we have close parenthesis, then down. Okay, for the negative NS and I is equal to 1 minus the negative, this one, over max. So max negative up to here. Sorry. Again, sorry, the formula. So max this value here. Okay, so let's drag this down. Okay. So step 7, calculate the appraisal AS for all alternatives. So the average, we will take the average of these two, the positive and the negative values SP. So is equal to average of these two. Then the last part is we have to calculate the rank of all the alternatives. So step 8, rank the alternatives according to the decreasing values of appraisal score AS. So the alternative with the highest AS is the best choice among the candidate alternatives. So we can justify the alternatives with respect to the ranking. So we will calculate the ranking. Rank this one. Wait. Sorry. Rank this one, comma, this down. Okay, so we can see here the first alternative is rank 5. Hmm, this is wrong. The formula. So we will do again here. Wrong. So this one. Okay. Yes, this is the value now. So we can see the ranking here. So first rank is alternative number 5. So the brand number 5 is the best choice in this example. Then followed by the third third alternative, then the fourth alternative. So this is how we can solve using the EDAS method. So as we know that the EDAS method proposed to handle the problems in which performance values of alternating each criteria for a normal distribution and have that assumption, and based on this we can the optimistic as well as the pessimistic appraisal score for evaluating alternatives and consider the certainty or can handle the uncertainty of decision making data. So these are all for my topic. Thank you and good morning.